You're welcome to my YouTube channel. Today, I will like to continue with the topic which we have started, the indefinite integral. So I just want to take an example, and I believe that the last video was helpful. So just an example. Let me just take an example. Let's say example 3. Example 3. In example 3, we are asked to evaluate the integral um, the natural logarithm of x dx. Now, in order to be able to solve this kind of problem using, don't forget, I think is it u dv? U dv equals to uv minus the integral of what? V du, if you recall. And so, using this ideology, I can say let my u to be equal to what? The ln x, right? Yes. And I can say that the v, right? The v to be equals to what? Dx. So this means this is the v. So basically this is 1 dx, right? This is dx. So this is the v, sorry. This is the v, and this is my u. So now I need to obtain my du. My du will be what? 1 over x dx. And I need to obtain my v here. My v is simply my x. So using what we have here, I have that the integral of the natural logarithm of this guy, of the v, dx, is equals to what? What is uv? This is x ln x, right? Minus the integral of what? Of what is my v? X. And what is my du? X dx. So this cancels out this one, and therefore I have natural logarithm x ln x minus what? So I am having the integral of the x here, which is simply what? X ln x minus what? Minus x plus c. So this is the final answer. Let's take now. Let me continue. Today, let me move to the integration by parts, considering a definite integral. So as we can see that the examples we've considered so far is the indefinite integrals, and it is indefinite because we have no bounds here. There is no bounds here, and that is why we are using the c. So so let me move to the second example, the second topic, which is the definite integral. Definite integral. Yes. So the difference between the one we've been doing so far now is that in the indefinite integral we have the case of a to b, let's say f of x, and g prime of x dx, right, is equal to what? Your f of x, g of x, now a to b negative the integral of ab f prime of x g of x dx. So in the u, if you try to put this in the u notation, so in the u v notation, I have, let me write, the integral of ab u dv equals to what? uv of ab minus what? The integral of ab, let's say phi du. So let me put this this guy. Yeah, so in doing this kind of a problem, I kind of advise students to use something like, for instance, a latte, and where your I is, okay, so what you are trying to do here is that you try picking u in the following order, to make your work very easy, because sometimes you might be in a case where you're trying to look at, okay, which one should I use as my u, or which one should I use as my dv, so we are going to consider cases like that. So in this case, if you see, let's say, the inverse trigonometry, so trigonometry, so if you see this kind of case in your integral, then you should make it your u. Then there is also the L, that is the logarithms, so just take it in this order. Then the A, if you have, let's say, an algebraic, so algebraic can be your polynomials, your roots, your rationals, and so on. Your T can be what? Your trigonometry, or trigonometric, sorry, it could be trigonometric. So trigonometric. Then your E to be your exponential. And I just also want to state out that your I and your L can be interchanged. That is, it depends on you. So it means I can choose this IL, I can choose it first, or I take it first. I take this part first. So it doesn't really matter.